Hello everyone, and welcome to the new episode of our series of solving LeetCode Daily challenges. And today we are going to solve a problem called Substring with largest variance, which is a hard problem. So without further ado, let's move to the problem statement. We define the variance of a string as the largest difference between the number of occurrences of any two characters present in the string. And we are given a string S, which consists of lowercase English letters, and we need to return the largest variance possible among all of the substrings of S. And let's take a look at the constraints. Our constraints tell us that the length of the string is no longer than 10,000, and that the S consists of lowercase English letters. And our examples also tell us an important information that if the string consists only of a single character, then we define its variance as 0. So for example, for the string BBB, the answer will be not 3, but 0. Okay, so what solutions can we come up with? The first one is to iterate through all of the possible substrings. There are a big O of n squared of them, and just calculate the variance for every single one of them. And we can calculate the variance in several ways. We can do it just like by keeping an array of counters, and each counter will tell us how many times a specific char appears in our substring. And we can do this basically with the complexity of big O of n squared times k, where k is the size of the alphabet. In this case, it's equal to 26. We can optimize this solution. For example, instead of this array of counters, we can keep a heap or even two heaps, one for minimum count and one for maximum count. And in this way, we can optimize our complexity to big O of n squared times logarithm of k, which is still kind of slow. I presume that with some smart optimizations, we can optimize the solution even further down, up to big O of n squared. However, this approach is still too slow, and with this type of constraints, I wouldn't risk implementing it. So we need to think about something smarter. And to do this, we will need to think out of the box. Okay, so suppose we have some substring which consists at least of two different characters, and the answer of this for this substring, the variance for this substring, is equal the maximum number of occurrences of a certain character, and we're going to call this specific char a bigger char, minus the minimum number of occurrences for some other character, and we will call this character a smaller char. Okay, so now we are going to turn this problem on its head. Instead of iterating through all of these substrings and finding this pair of bigger char and smaller char, we are going to iterate through all of the possible pairs of bigger char, smaller char, and we will try to find an optimal substring for this specific pair. And our result will be the best result among all of the possible pairs of bigger char and smaller char. And now I'm going to show you a couple of examples that will help you to understand how can we implement this. So suppose we are iterating through all of the possible pairs of bigger char, smaller char, and now we have bigger char equals to b and smaller char equals to a. Okay, so our first thing that we need to take into account is that our answer, our variance, will be 0 until we have met both of the chars. So for example, in this string, our answer will be 0 until we meet this last letter of a. And the total answer for this substring is equal to 4 because we have 5 letters b and 1 letter a. Okay, and this is important, and this will be reflected in our code. Okay, the next observation that we can make is that our optimal substring can start from a smaller char, but we don't need more than one such character. Why is that? For example, suppose we have this substring of a b b b b b. We still need this char a, because otherwise our substring will contain only one character and the variance will be equal to 0. But if we will take a look at the next string, we don't need more than one letter a in our optimal substring, because if we take the substring of AA and then 5 letters B, then the answer will be equal to 3. We can optimize this solution by taking only one letter A and basically then take the 5 letters B, and the answer will be 4 again. So yeah, from time to time we need this leading smaller char, but we only need it to make sure that our string contains 2 different characters, at least 2 different characters. And we never need more than one such character for that. Okay, and the third very important observation is that it is important for us to know whether our substring have started with smaller char. And why is that? Okay, suppose we have a string that looks like that, and we are going to iterate through it from left to right, and we are going to keep the difference between the number of bigger chars that we have encountered and smaller chars that we have encountered. So at first we've encountered a smaller char, and we will note that now our string starts from the smaller char. Then we will encounter 3 occurrences of bigger char, and now our currently answer for this substring is equal to 2, because we have 3 letters B and 1 letter A. Then we are going to encounter a smaller char, so the letter A. And what I'm telling is that now that we know that our substring started from the smaller char, we can actually drop it and move from this string to this string without changing the result. And this is very, very important. So if we know that our substring started from the smaller char, we can at some point just drop it if we can, and that will not decrease our answer. It will only help us to make the answer better in the future. Because remember, we need this leading smaller character only to make sure that our substring contains at least 2 distinct characters. And if somewhere along the way we also have encountered this smaller char, then it's safe for us to just drop this leading smaller char. And yeah, so basically we will transition from this substring to this substring with the answer of 2, and then we will pick up this letter B, and our answer will become equal to 3, which is already better. So that's great. But we need to remember that we can do this trick only once. So for example, if we encounter the next smaller char occurrence, then our answer will decrease and it will be equal to 2. However, after that, we can also find these 2 letters B, and the answer will be equal to 4, because here you can see in this string we have 6 letters B and 2 letters A. And that basically describes our solutions in some details, but of course I will show you the code. So our main function is pretty straightforward. We are iterating through all possible values of bigger char. Inside we iterate through all of the possible values of smaller char. If they are the same, we just dismiss this case, and otherwise we are updating our result with the answer that we calculate for the specific value of bigger char and smaller char. So everything is pretty straightforward in here. The interesting part is how do we calculate the answer for this specific pair of bigger char and smaller char. Okay, and I will show you just that. We will need a couple of variables for that. So the variable res is obviously going to carry result. The variable balance, we will store in it the difference between number of occurrences of bigger char minus the number of occurrences of smaller char. And we will need this variable to update the result. And we will also need to have two different Boolean flags. So the first one is called encountered smaller char, and basically it will show whether we have already encountered a smaller char, and it's needed because of this very first example. Our answer is 0 until we have encountered a smaller char. And the other flag that we will need, we will call it allowed to not count smaller char. And this flag will basically describe to us this situation, that if our substring have started from a leading smaller char, then at some point we can ignore it. So we can transition from this string to this string without making our result worse. Okay, so we have these variables. Now we are going to iterate through all of the characters in our string. And if the current character is equal to something else, to something not equal to bigger char or smaller char, we can just dismiss it. At this stage, we are not interested in it. And if our current char is equal to our bigger char, then we should just increase this difference in number of occurrences of bigger char minus number of occurrences of current char. So yeah, also pretty straightforward. But yeah, we have a very interesting case of what happens if we encounter a smaller char. So first of all, we will set this flag to true, that okay, we have already encountered a smaller char. Then we have a couple of cases. The first case is if we are allowed to not count smaller char, then we will not decrease our balance. We will just flip this flag to false. And if we are not allowed to not count smaller char, then we have to flip the bounds. We have to decrease the bounds. Sorry about that. And in the end, we are going to take a look. If our balance is less than 0, it means that currently we have more smaller chars than bigger chars. And if that's the case, as I've said, there is no situation where we need more than one of leading smaller chars. So we will tell our solution that the balance is currently equal to -1. Even if it's smaller than -1, we will still store a -1 in this variable, dismissing this consecutive leading smaller chars. And we will also flip this flag of allowed to not count smaller char, because yeah, it means that currently our substring starts from the leading smaller char. And in this case, we're allowed to skip it further down our solution if we will need to. Okay, and in the end, we will check if we have already encountered smaller char, then we can try and update our result and say that it's equal the maximum between result and bounds. And that's pretty much it with this solution. Okay, what's the complexity of this solution? So our complexity is big O of k squared times n. And I will remind you that by k we define the size of the alphabet, and by n we define the length of the string. Why is that? Because in these loops we have two nested loops which iterate through all possible pairs of chars, and there are exactly big O of k squared of such pairs. And for a fixed pair, we do a check with the complexity big O of n. So our total complexity is big O of k squared times n. Oh, also, I wanted to show one more example before we wrap up. So you might say that, okay, suppose you have a string like that, and suppose you have chosen the bigger char equal to b and smaller char equal to a. The optimal substring for such a pair is basically the whole string, and the answer for it will be equal to 3, because we have 4 letters b and 1 letter a. And you can actually tell that if I'm going to take a look at the string, the answer for it is bigger than 3. So does it mean that we've missed out? And my answer to that is no, because the answer equal to 3 is only optimal for this pair of B and A. However, later on in our algorithm, we are going to consider other pairs as well. So for example, when we will consider the pair of C and B, C is a bigger char and B is a smaller char, we will be able to find out this substring, and the answer for it is equal to 4. And even more than that, when we will consider a pair of C and A, where C is a bigger char, we will be able to find this substring, and the answer for it will be 5. So basically, when we consider a pair of bigger char, smaller char, we are only interested in the optimal result for this specific pair, even if the substring that we have has a better result for some other pair of chars. Okay, so what lessons can we take from this problem? So first lesson that I would suggest to you is, if you have an easy solution for a problem in mind, don't forget to mention it to your interviewer. It would be cool to let your interviewer know that you know how to solve this problem, for example, with a solution of complexity of big O of n squared times k, or even better, big O of n squared times logarithm of k. And yeah, it's pretty cool. Your interviewer will appreciate it. And the other suggestion that I would recommend you to do during the interview is sometimes try to think out of the box. So in this problem, instead of iterating through all of the possible substrings and looking for an optimal pair of characters, we did the opposite. We iterated through all of the possible pairs of characters and tried to find the optimal substring for this pair. Okay, guys, thank you very much for your attention. This problem is not easy. However, yeah, I did my best to explain the solution. Hope you liked it. If you did, please press like, subscribe, leave your comments. I will try to answer to all of them. Thank you very much for your attention and have a good day. Bye-bye.